Hello guys, so this is the big LabVIEW program we've developed during this summer for streamlining all data collection and analysis when undertaking an experiment. Emily and I complained to Dr. Bolkohide of how difficult it was to follow with the process, and this is what we've produced. This LabVIEW program has a lot of tabs from left to right, and that makes it easier to follow along with the process. We use LabVIEW because it served as a very good graphic user interface to interact with the program, but underneath it there are a lot of Python nodes on which important programs run. Talking about tasks, I developed the data collection part of the program, that is collecting impedance data, voltage and temperature data, and writing and reading this data from memory. Dr. Bolkohide used the impedance data to calculate coparameters, that is resistance, capacitance, and inductance of both the M and H coils, and you use these values to obtain the G factor. Emily's part was to analyze voltage data to find the coordinates of the MH function curve and write this data onto memory. So this is the first tab of the program. This basically shows where the data should be stored, and this basically tells you the file path for today's data. And we have a path that basically gives you a chance to write a short comment about today's measurements, and that will be written into the file where the data is stored. And this basically gives you a long comment. So today's sample is not anything special. It is just an empty sample. So basically you write the sample data, and then you move on to the next tab, which is collecting H coil impedance. So we're going to run using the VNA, and then we get the data. So it runs, and there you have it. The magnitude and phase of the impedance data. And then you move on to the next tab, which is finding the H coil manual fit. So basically trying out values of capacitance, inductance, and resistance, and trying to simulate these values for the H coil. So this was we initially used a 5-spice simulation program, but then Dr. Bolkohide converted that to a Python node program. So you're going to run it using date file, simulation 1, simulation 2. This is simulation 1 parameters and simulation 2 parameters, and we run it and try and see which one is very similar. So you can see simulation 2 is really far off, so you put that off and try and see simulation 1, and it looks quite close. I think we have to do some we have to change some of the simulation parameters, but this is for demonstration only, so we have to move on. Then we tried the H coil automatic fit, so it's going to take a few minutes. So he's done with the fit. As you can see, it's not really that close, so that means we have to change the initial values the next time we run this, so as to make it much more closer to the actual values. So then we move on to calculating the G factor, and we basically have options: read data from a G factor file, but then we don't have a file to run on. We are doing a fresh experiment, so we're going to use recorded and analyzed data to obtain a G factor. And if we are calculating the G factor, we have two choices: to use the values from the manual fit, which is from simulation 1, or use the automatic fit, which was the one that we got from here. So we have to look at which one is closest to it, and I think that the one from the automatic fit is much more closer to it in value. So we're going with that, and you're going to use that to calculate for the G factor. So that gives you the G factor with the values. And then we have to do the same process for M. So we have to get M impedance data. So we're going to measure it from the VNA. So we have that. And we have to do an M coil manual fit, and we have to move on to the automatic fit. And I feel like the automatic is much more closer than the manual. So you're going to choose the manual, use recorded and analyzed data to obtain G factor, and then use the fit parameters from automatic fit to find the G factor. And that is the G factor curve for magnitude and phase. And then we record temperature values. So basically, voltage data source, do we measure with oscilloscope or load from data file? We are going to measure from oscilloscope. And the number of collections is going to be 3. So we're going to do 3 runs. And we're going to get the data. So we have the voltage with time of this is for the H coil, and this is for the M coil, and this is the temperature values for each run. So the white one is for the first run 1, the red line is for run 2, and the green one is for run 3. And you can see the individual plots from here. This is for run 1, this is for run 2, and that is for run 3, and all of them shown on the graph looks like this. And from that, use all this data to analyze the MH, which is going to be shown in Emily's video, and write this data into Excel.